Hello, welcome back to Algebra. Here in this lesson, we're going to start solving inequalities that involve one variable. This is the first of a few lessons where we'll start with very easy problems, and then we'll gradually increase to more and more complicated problems so that you get lots and lots of practice. All right, so the main thing is up until now we've solved equations. We've done a great review of getting ourselves familiar with how to solve equations with multiple steps. We move the things over to one side of the equal sign, we get the variable to one side, and we divide or multiply to get that variable by itself on one side of the equal sign, and then we know what it's equal to on the other. Now we're going to be dealing with inequalities, so we're going to be replacing the equal sign with a less than, or a greater than, or a greater than equal to, or a less than equal to. The rules of solving these inequalities are exactly the same as solving equations. We move things over, we get the variable to one side of the inequality, we divide or multiply, and that's what we're trying to do. There's one main difference, one thing that you have to keep in mind as we solve inequalities, and I'm going to wait to tell you what that is until we can get to an example so I can show you rather than just tell you. So let's start with a really easy inequality, just to show you what I mean. First, we're going to recall what an inequality is. So we're going to talk about, for instance, the inequality x greater than 3. What does this mean? This means that the variable x is not equal to a number. It's not just 5 or 6. X is a whole range of numbers. It can be really infinity numbers, right? Because what we're saying is, since it's greater than 3, we're saying that x can be 4 or 5 or 6 or 7 or 8, but also the numbers in between, like x can be 4.5, x can be 3.012. As long as it's bigger than 3, notice there's no equal sign. If there's an equal sign under the inequality, then you would have to include 3. Any number bigger than 3, 3.01, 5.79, and so on, that is what x can be equal. It's a whole range of values. So in order to graph that, x is greater than 3, what we do is we go to number 3 on the number line up here, and we put an open circle. The open circle means that, obviously 3 is the number we care about, but we're not including the number 3 in the solution. And what we do is we shade everything to the right of this on the number line. So if you can see that, what it means is everything bigger than 3, 4, 5, 6 on to infinity, and all of the numbers in between, like here's 3.5, here's 4.5, and so on. The open circle means we are not counting the number 3 in our solution. All right, let's take a look at another really simple one. Let's say we have x is greater than or equal to 2. So this is the exact same thing, except we're also including the number 2 in the range of x, because it's greater than 2, or it's equal to 2 as well. So we represent that by finding the number 2 in the number line, and we put a solid dot in place instead of an open circle, and then we shade everything to the right. You can put a little arrow at the end if you like, showing that you're going on and on to infinity. So this open circle means we're not including the number 3, everything to the right of it though. This closed circle means we're including everything to the right of 2 and also including the number 2. So if we had the inequality x is less than 1, for instance, that would mean everything smaller than 1. So it would be 0, -1, -2, and so on to the left of 1. So we go to the graph, to our number line, we find the number 1, which is right here. It's less than, but it's not equal to 1, so we put an open circle here, and we shade everything to the left. All of these numbers. So all of these negative numbers, and also the numbers between 0 and 1 here, but of course not including the number 1 itself because it's an open circle like this. So open circle versus closed circle is very important there. Now we have one more just to kind of wrap it up and just kind of give you one of the really basic examples. What if we had x is less than or equal to -2? Less than or equal to -2. So first you find -2 on your graph. You see that it's less than or equal to. So we find -2. It's going to be a closed circle because it's also equal to -2. And we're saying the variable x can be less than or equal to that. So it means we shade to the left. So basically what we're going to do for all of these inequality problems is, this is just kind of a basic review of what an inequality is. But now what we're going to do is we're going to start solving inequalities where you have to move things to the left and to the right-hand side, but the goal is at the end you want to end up, get an equation, you want to end up with x equals 5 or x equals -2. Here you want to end up with x is less than or equal to -2, or you want to end up with x is less than 1. So you want to move everything to the left, everything to the right, so you have variable by itself, and then once you get the answer, you graph it. So you basically, the answers to all of these things are going to be ranges of values. So that's the difference between an inequality and an equation. An equation means they're equal. There's one solution generally for a simple linear equation like this. But for inequalities, there's a whole range of solutions. So just to give you an example of one of the very simple ones, let's say we had the problem x minus 7 is greater than negative 5. So if x minus 7 is greater than negative 5. So what you do first of all is you just pretend that this is an equal sign right here. You pretend it's an equation. So if this was x minus 7 equals negative 5, what would you do? You want x by itself, so you have to get rid of the 7. How do you do it? Because the way you do it is you do the opposite of the negative. You add 7 to both sides. So what you would get when you add 7 to the left is just x will be by itself because 7 and negative 7 will add to 0. On the right, you'll have negative 5, and you'll have to add the 7 to it. So what do you get on the right-hand side? X is greater than. What do you get when you add these? You subtract them, and the sign goes with this one. You'll get a 2. So this is not saying that x is equal to 2. This is saying that x is a range of values bigger than 2. So you go up here to represent the solution as a graph. You go and you find the 2 on the number line. You put an open circle because it's not greater than or equal. It's just greater than 2. And then you shade every number larger than this. So what this means, it's very important in math to understand what you're doing and what the solutions mean. What it means is, just like for an equation, you had one solution. You can take that solution and stick it back in the equation and show that that solution is correct, that makes the equation equal, right? With the inequality, what we're saying is any number bigger than 2 actually makes this inequality work. So you can check it. Let's take the number 3, because that's bigger than 2, right? What we're saying is any number bigger than 2 should work. So let's put it in here. What is 3 minus 7? 3 minus 7, if you think about it, 3 minus 7 is negative 4. And my question to you, is negative 4 greater than negative 5? Now it might be a little bit weird to say that, but if you look at negative 4, and here's negative 5, negative 4 actually is larger than negative 5. They're both negative, so you have to think about it a little bit, but negative 4 is actually larger. Now if we pick a number even bigger, let's pick 10, because that's also bigger than 2. Let's put 10 minus 7. What is 10 minus 7? 10 minus 7 is 3. Is 3 larger than negative 5? Of course, 3 is over here, negative 5 is over here, so that would satisfy as well. So you see, as you keep plugging numbers larger and larger and larger in, it's going to get more and more and more greater on this side, so it's always going to work. Now what happens when you put the number 0 in here? Because that's not going to work. It's not greater than 2. Let's put 0 in. 0 minus 7 is negative 7. Is negative 7 greater than negative 5? Whoops, and put a question mark. No, it's not. If you look over here, negative 7 will be over here. That's definitely not bigger than negative 5. So you see, when you get the inequality down to the end, you're getting a range of values, and those values are what would work when you put them back into the inequality to begin with, and so on. That's what the idea is here. So let's do one more simple one before we move on to a little more complicated ones. What if we had 2 times the variable t is greater than 6? So you basically just, in your mind, envision or pretend that this is an equal sign. What would you do? Well, I would divide this. I would have 2t less than 6. I would divide the left by 2. And if I do that, I have to divide the right by 2. And I do that so that this cancels. So I would get t on the left. 6 divided by 2 is 3. So what I would do if I wanted to graph this is I'd have to find the number 3, which is over here. I'd have to put an open circle because it's not less than or equal to. It's just less than. And then all numbers to the left of 3. So I would go to my graph here and I would shape everything to the left. So any of these numbers to the left of 3, but not including 3, would work. So just pick one. Let's stick a 0 in. 0 is less than 3, right? So 2 times 0 is 0. That is less than 6. That works. What if you put in negative 1? That's less than. Negative 1 times 2. That's going to give you negative 2. That's also less than 6, and so on. But if you go the other way too far, let's put 10 in. 10 is definitely not less than 3, so it shouldn't work. 10 times 2 is 20. That is not less than 6. Now let's look at the special point. What happens when you set it equal to 3? 2 times 3 is 6, right? So you say 6 and 6, but notice it's an inequality. What is on this side has to be less than what's on the right. But 6 is not less than 6. 6 is equal to 6. So the number 3 itself is not part of the solution because when you put 3 in here, it doesn't work because 6 is equal to 6. That's not less than. That's why we have an open circle here because the number 3 doesn't work for the solution. So as we go through here, we're going to solve a few more problems, getting practice, and graphing every one of these solutions on the number line. All right, for our next problem, let's say we have negative 5x is less than 10. Negative 5x is less than 10. So you treat it like an equation. Now what you need to do is you need to divide both sides by what? By negative 5 to get it by itself. So what we'll have is, just to make it 100% clear, let me rewrite this so I don't kind of mess up the first thing that I wrote down here, the problem statement. Let me take this away for right now. We'll take that away from right now. So what we're going to do then is we're going to divide the left side by negative 5, and when we do that also we have to divide the right side by negative 5. Now if you remember back at the beginning of the lesson, I told you that solving inequalities was exactly the same as solving equations. I mean, you use the same rules, except for one thing you have to remember, and this is that thing. When you divide both sides of this inequality, or if you multiply both sides of this inequality by a negative number, any negative number, then what you have to do is this inequality sign, you have to flip directions. All right, that's a general rule. I could go into why you have to do that, but honestly, it's not worth doing, because ultimately there's a reason, and it has to do with the number line and what happens when you divide by a negative number. But the bottom line is, every time you solve an inequality, if you divide by negative 5, you have to flip the direction of the arrow. If it's a less than or equal to, then you would flip it to greater than or equal to. If you divide by negative 2, you're going to flip the sign of that arrow. If you divide by negative 17, you'll flip the sign of that arrow. If you divide by negative 0.5, you're going to flip the sign of that arrow, right? Now here's the thing. Because division and multiplication are related, right? The same thing happens when you multiply by a negative number. So if I have to multiply this by negative 10, I'm going to flip that arrow. If I'm going to multiply this by negative 1/2, I'm going to flip that arrow. So it's a very simple rule to remember. Anytime you multiply or divide an inequality by a negative number, you flip the sign of this arrow. If you don't do it, you will get the wrong answer. So what do we have? We have the negative 5s canceling with the negative 5. So on the left, you have x greater than, now, what's 10 divided by negative 5? That's negative 2. So this is the final answer. X is greater than negative 2. So the way you graph it is you go up and find negative 2. It's not greater than or equal to, it's just greater than. So you put an open circle because we're not including the number negative 2 in our solution, and we shade everything to the right. That's the graph of this inequality. All right, what if we had the inequality negative t over 2 greater than 3/2? There's a lot of different ways to do this. I can think of 2 ways right now, but what we're going to do is we're going to try to get rid of this. Let's do it like this, 3/2. We're going to do it like this. We're going to take the left-hand side of this guy, since we're multiplying by negative 1. We have a negative 1/2 here, essentially. What we're going to do is we're going to multiply by negative 2 over 1. Right here. And when we do it to the left-hand side, we also have to multiply the right by negative 2 over 1. Why are we multiplying by negative 2 over 1? Well, first of all, we're multiplying by negative so we can kill the negative sign. We don't want any negative signs on the left. And 2 over 1 will cancel with the 2, because the 2 will cancel with the 2. So the only thing you'll have left when the negatives cancel is a t on the left-hand side. But when we do this multiplication, we must flip the sign of this inequality. So we'll have less than, and what do we have here? The 2 cancels with the 2, but now we have a negative. Times 3 means negative 3. This is the final answer. It works exactly the same. This is exactly what you would do if you had an equal sign here to get this by itself. But of course, with an equal sign, you don't have to flip the direction of anything. Here we had to flip this direction. So to graph it, we go find negative 3, and we put an open circle because it's not equal to negative 3. It's just less than negative 3, and we shade everything to the left. All right? That's basically it. Let's do one more. Since these are so small, I think I can fit it on this board. What if we had 3x minus 1 is greater than or equal to negative 4? Now the only difference between this and the other equations, obviously there's a negative 1 term here, is now we have greater than or equal to. So it doesn't change how you do it. If it's greater than or equal to, you just have to carry that sign down throughout. And of course, if you have to flip the direction, because if you divide by a negative or multiply by a negative, then you'll flip it to the other direction with an equal sign under it. So what we do now is we say, what do we have to do first? If this were an equal sign, we would get rid of the 1, so we would add 1. So it would be 3x greater than or equal to. We add 1 to the left, we add 1 to the right. What is negative 4 plus 1? Negative 4 plus 1, negative 3 on the right. Make sure you understand, add 1, add 1. All right? And then what do we do to get rid of the x? Well, we have to divide by 3. So it'll be x greater than or equal to negative 3 on the right. We have to divide by that 3. We divide the left by 3, killing it. We divide the right by 3, and what you get at the end of the day is x greater than equal to, what do we have? Negative 1 here. This is the final answer, x greater than or equal to negative 1. So now, to plot this, we find negative 1, and we put a solid dot because it's greater than or equal to negative 1, and then we shade everything to the right. All of these numbers, including the number 1, negative 1, will be correct. If you stick them into this value of x, it will satisfy this inequality. In fact, if you put negative 1 in here, because we're saying it's greater than or equal to negative 1, if you put negative 1 in here, what will you get? 3 times negative 1 is negative 3. Negative 3 minus 1 is negative 4. Negative 4, is that greater than or equal to negative 4? Yes, because it's equal to, which is allowed in this inequality. So the answers that you get, you should be able to put them back in and verify that they are correct. All right, what if we had the inequality less than or equal to 7 times y minus 24? Now, first of all, just like with equations, in inequalities, you'll see all kinds of variables running around. Sometimes you'll see x, sometimes you'll see y, sometimes you'll see t, sometimes you'll see a or b or w, it doesn't matter. You treat it all the same. It's exactly the same. You're trying to find out what values of y work with this inequality. So what you do, first of all, is you have to collect all the y terms on one side, all the other stuff on the other side, and that's what you need. So in order to get this done, how do you get this 7y over here? Well, this is a positive 7y, so to move it over, you have to subtract it. So on the left, it'll be y minus 7y. On the right-hand side, it'll be 0 here because you subtracted 7y, and you'll have the negative 24 that's still there. So we subtract 7y from the left, we subtract 7y from the right, that makes it 0. And what do we have when we do this subtraction? 1 minus 7, you should know now, is negative 6y, and it's going to be negative 24, right, like this. So what's the final answer? To get y by itself, what do? We have to divide by a negative. Remember, divide by negative means we have to flip that sign. So when we divide by the negative 6, we'll have y by itself. This sign, at this point, flips around. Notice we have an inequality with an equal sign, so it flips the other direction. And what is it going to be over here? Negative 24 divided by negative 6. So we divide by negative 6, divide by negative 6, and the final answer will be positive, because negative divided by negative is positive. 6 times 4 is 24. So it's y greater than or equal to 4. Now, to plot this guy, we go find the number 4. We put a solid circle because it's greater than or equal to, and all of the values to the right of that is what we have. So 4, 5, 6, 7, and so on. If you stick them in here, you will find that this inequality is satisfied. All right, now we have one more that we're going to do in this lesson. What if we have 2x, whoops, not 2x, 2 minus x, that's what I was trying to write, less than 4 plus x. So it's the same sort of deal with equations, right? You have some x's on the left, some x's on the right. You got to move the x's over here, you got to move the numbers over here. So what do? We're going to subtract x to move it over here. So what do we have? 2 minus x from here, but we're going to subtract x, so we'll have another minus x, then we'll have the less than sign, then we'll have a 4. When we subtract x from the right, then this becomes 0 because x minus x is 0. We subtract x from the left, we have written it out here, and then the next step we'll say it's minus 2x less than 4, just like this. Now we have to take the numbers, the number 2, and move it to the right by what? This is a positive 2, so we'll have to subtract 2. Like this, whoops, not equal to in this case. We'll have 4 minus 2 on the right. So we subtract 2 from the left, it disappears, subtract 2 from the right, and what we have is negative 2x less than 4 minus 2 is 2. Right? Now what do? In order to get x by itself, we divide by negative 2. So you remember we divide by negative, that means we flip the sign of this arrow, and it'll be on the right, 2 divided by negative 2. On the left we divide by negative 2, it disappears. On the right we divide by negative 2, and what we get is x greater than negative 1. 2 divided by 2 is 1. Positive divided by negative is negative. So what we have is x greater than negative 1, but not equal to negative 1. So we put an open circle here, and then we shade everything to the right. Open circle at negative 1, shade everything to the right. So just to pick an example if you want, notice we're saying x is greater than negative 1, so we're saying 0 should work, right? Just as this single example to put in here, 2 minus 0, that gives us 2. 4 plus 0 gives you 4. 2 is less than 4. It works. And so you can pick numbers on the left and on the right and just kind of make sure. But essentially, this defines a range of values that work when you use them and plug them back into your initial inequality. So that's a really good overview of solving inequalities in what we call one variable, right? Because later on we'll have inequalities that have two variables, and we'll get to that later on down the road. But these skills that you're learning here are absolutely essential for you to understand how to do more complicated types of problems. So follow me on to the next lesson. We'll continue solving inequalities, and we'll make the problems slightly more complicated along the way, but essentially we'll be doing the same things as we're doing here with just a few more steps when the problems get a little bit more challenging.